Hi everyone. One thing I wanted to check out before I start putting components back in here is to check out a couple of things. One of them is the volume control. I hooked up my RCA senior volt ohmist here, and I'm checking out the resistance of the pot because I noticed that when I turn the pot it's very hard to turn, and I wanted to show you inside this potentiometer is a wiper, and that wiper rubs against this material. I think it's some kind of carbon material. Anyways, and as the wiper goes along there, it changes its resistance. Well, if you ever had a radio and you noticed that it was scratchy when you turned up and down the volume, this is a classic signature of that, and I'm going to show that on this meter. I've got the meter hooked up to the potentiometer, and as I slowly increase, watch, this meter should increase in value smoothly, and as you can see it's jumping all over the place. That would be a classic scratchy volume control right there. Can that jump around? Now it's smoothing out, now that I'm pretty close towards the end, but the last 1/4 turn is pretty smooth. But once I start getting about halfway, you can see there it goes jumping all around. See, it goes up, down, up, down, up, down, up, down. Okay, there's all kinds of fancy cleaning materials that you can use, but this one guy that I know runs a website. He's been using this stuff on controls for over 10 years with not a problem. And some components you may not want to use stuff like this, well, maybe some wafer switches and things like that, though I have used it myself on wafer switches without a problem too. So the shaft itself is hard to turn, so I'll lubricate it with it too. It's a great conductor, so and it's cheap, so you don't have to buy all this expensive chemical stuff. Sometimes you want it, sometimes it doesn't matter. Something as simple as a potentiometer, I'd just go with this stuff. And then usually you can find a spot in the control where you can squirt some of this stuff in. If you look, even though this thing was made in the 30s, the pot here, the outer casing looks like it's made out of either a Bakelite material or plastic. If it's plastic, I'm amazed, because this is the 30s we're talking here. Usually these things are made out of metal. And I don't see a place to squirt WD-40 in, or any material in, very good. I do see one tiny spot right here, and I'm going to try to see if I can get something in there. And I think it is getting in there. And we'll try rotating the dial a few times again. It does seem to be a little better, but it's not perfect by any means. Let's give it a few turns. I'm also going to lubricate this shaft because it's hard to turn. Just squirt some down there. Should wick in. There we go. You don't want to use too much because you don't want to get stuff all over the place. Give it a few turns, see if it feels like it's going to free up at all. It's still pretty rough. It's way rougher than it should be. Let's see if no, it's still jumping all over the place. Oh, it's a little bit more down the shaft. Alright, it's finally starting to smooth out. The shaft is much smoother now. Okay, I think that's pretty good now. Alright, the other things I want to ohm out, and I think I'll just do it with my digital meter just because it's easier, is I never tested the coils on the IF cans. There's 2 IF cans here, okay, and there's 2 sets of coils, and you want to make sure that they're not open. Alright, so I guess we'll do that next. Okay, there's 2 IF cans in this radio, and each IF can has 2 coils. 1, 2, 3, 4. And we'll test these out by ohming them out. And they should be very low ohms, like 15 ohms, 13 ohms, 11 ohms, 12 ohms, somewhere around there. And that'll tell us if these are open or not. It may not tell us if there's a shorted winding or not, but at least it'll tell us if it's conducting. So go ahead and do that. Okay, up here is one of the cans. If you look closely, there's a blue and a red wire coming out of there. That goes to one of the coils. And then there's a green, and it looks like a black wire, yeah, a black wire coming out the other hole. And same with here. Down this other IF can, there's a black and a blue, and at the lower one there's a blue and a red. Sorry, that top one is green and black. So I would imagine these IF cans are identical part numbers. So it makes sense that the wires are the same colors. Okay. So, well, knowing that, I'd probably be better off just testing it this way. If this reads a certain amount of ohms, then the identical coil in the other IF can should read the exact same. So if you match them up like that, you could probably get even a better determination of whether, you know, besides them conducting, whether they jive with each other as far as, like, you know, if there was a couple of shorted windings, maybe it would be slightly different. If you get the exact same amount of ohms, there's probably a pretty good chance that they're both fine. So let's try it that way. Okay, so we put a green, attach this cable to the green wire, and this one to the black, and we have a reading of 12.8 ohms. That sounds good to me. So if we go to the green and the black in the second IF can, black goes to here, and the green goes to, good question, it looks like right here. And I got 11.8. So we got what was it, an ohm difference? The other one was 12.8. Let me go recheck that again. But it's different. Now I don't know if that necessarily means it's bad. You know, whether it has a couple shorted windings or something. But they do show different. 12.7 and 11.8. So, a little more than an ohm different. So, well, we'll just keep going. If I put the whole set back together and it plays just perfectly, then I would assume it doesn't have shorted windings, because the shorted windings would change its resonance. So, in other words, it would shift off frequency. It would be like detuning the slug inside the IF can. So, if it plays nice and strong, then I would assume that it's probably okay. I could go through an IF alignment, but if it plays okay, I don't know if I'm going to bother going doing that. So, it's mainly going to be used as a record player. If the radio works, that's fine. If it works great, that's even better. But it doesn't have to work perfectly in this particular instance. Okay, the other coil, which is a blue and red wire, on the top IF can, reads 13 ohms exactly. And let's see, the blue wire on the bottom one goes there, and the red wire on the top, on the bottom one goes there, and we have 12.3. Well, again, one IF can is slightly different than the other. So, it's possible maybe they aren't exact part duplicates. Maybe they are different part numbers. Maybe internally it is a little bit different. Although in the schematic, it's just a second stage of IF amplification, so you would think they would use identical IF cans, but perhaps they don't. So, but one good thing though that makes me a little bit happier here is this one read 1 ohm different than the other one, but in both cases, so it's consistent. So I don't think it's probably like one bad coil, and I can imagine 2 bad coils. So it's probably just the way it was constructed, and perhaps that's the way it was made to be that amount of resistance. Now, but perhaps maybe one IF can was made from one manufacturer, and the other IF can was made from another manufacturer, or a different lot line or something. And so they aren't like exactly the same, but maybe it's tunable using the slugs when they manufactured this thing, so you can get them in resonance even though they're a little bit off. I don't know what the case is here, but at least they're consistently off on both coils on both of them. So I would still say that it's probably okay. So I think at this stage I'll probably fire up my soldering iron and start proceeding. I did get all the parts in for the resistors and capacitors, so we can start installing stuff, and I guess I'll start with the resistors. And let me think about this. I could actually start with the capacitors, and I would actually have more room. Because what I don't plan on doing is a lot of my older stuff that I repaired is I restuffed the capacitors. I would heat these up, melt out the wax, take the new part, wrap it in some kind of paper, because they're always smaller than these original ones, so they fit tightly in there, and then fill it in with either beeswax or hot glue. I even have some colored hot glue that looks kind of brownish like the original. But in this case, the person I'm giving this to will never look under the chassis. I don't think they could care less if it's got modern components in it, so I'm not going to go through all the bother. So if I replace all the capacitors first, and maybe this is the route I'll go, then it will make a whole lot of room in here, and then be a lot easier to get to the resistors that I need to do too. So I think that will be the plan, to replace the capacitors first in this case. So that's what we'll do next.